Welcome to this NPTEL course on Advanced Pre-Stress Concrete Design. We are moving into the new module, Module 8, which is going to be on composite construction. Right, the expected learning outcomes are the student should be able to understand the concept, types and applications of composite construction, and the student should be able to analyze the stress distribution in propped and unpropped composite construction depending upon how the precast elements are supported. We have two types of methods of construction, propped and unpropped. The stress distribution will be different, that we will understand, and then the student should be able to estimate the deflection for the propped and unpropped cases. Then when you go for composite construction, there will be a differential shrinkage. The student should be able to explain what are the implications of differential shrinkage, and then apply the concept of horizontal shear transfer to transfer adequately the shear without any slip between the precast and cast in place slab element. Then finally, we will end the module with one design example on how to design a composite pre-stressed beam section. Right. So, composite construction, as you know, the name suggests, typically we are going to combine a precast element and cast in place concrete systems to create a monolithic structural member. So, a composite precast pre-stressed beam combines precast and cast in place concrete systems to create a monolithic structural member. Now, what are the components that are there? Usually in composite construction, precast pre-stressed beam will be used. Usually they are manufactured as an I girder or T-beam or a box girder with pre-stressing tendons, and over which the cast in place slab will be provided. So, the concrete slab will be poured on the forms the top flange of the composite section. So, whatever the slab that we are pouring on top of the precast system, that will become the top flange for the entire composite section. So, that is how it is. What are the key benefits? Because we are employing precast, we are avoiding the cast in place concrete construction, or I should say we are minimizing the cast in place construction. You are supposed to have good quality control, and because we are using precasting and we are just erecting, so the construction time is expected to be less, and it is supposed to have superior structural performance. These are the benefits. We are avoiding actually formwork also, right? Greatly the formwork that is required for cast in place construction, maybe very minimum amount of formwork only will be required. So, these are also one of the benefits of composite construction. Now, what are the typical cross section and applications? So, you can see here usually double T's are provided, particularly in precast buildings and parking garages. And then on top of this double T precast pre-stressed elements, you provide cast in place slab typically to create a continuity, which is also called as a diaphragm action. Overlay is actually provided. This is usually called as a overlay. Usually this is made from cast in place construction. This is used in industrial buildings and long span bridges also. And in precast construction, hollow core slabs are very commonly used. Now, how do you tie all the individual hollow core slabs into one unit? You provide a cast in place slab or a overlay that is going to connect everything, and it is also going to create a diaphragm action. In bridges, for short to medium span bridges, typically the beams are made with pre-stressed precast concrete, and then the deck slab is provided using cast in place construction. So, this is basically a deck slab, right. Then parking structures, again you have this wide flange, T sections are used. On top of that, again we provide cast in place concrete as a overlay to create continuity. Now, from bridge point of view, again you can see here typically the pier foundation is done using cast in place, and then we run the precast girders along the length of the span. Then we provide cast in place slab, and then some crash barriers are also we add. This is the typical cross section of a bridge. Now, the girders are made using precast, deck slab is usually done using cast in place. Now, this is the way the loads are going to act. Once everything is joined together, the deck slab hardens, then the entire system acts as a one unit in a monolithic way. Now, what are the types of composite construction? So, we can combine precast and pre-stressed elements along with cast in place slab, as we have explained before. We have again precast girder, and this is your cast in place slab. So, we have talked about that, and this is a one. So, it is going to give me enhanced structural performance. It can allow for longer spans and thinner sections because we are doing it in the factory. Again, precast elements can be designed as a type 1 element or type 2 element with improved crack control capabilities. Another option is I can also combine steel girders along with cast in place. That is also a composite construction where we are using both steel and concrete instead of precast, pre-stressed element and cast in place. Now, I have steel. I am replacing the precast girders with steel girders, and then cast in place construction or concrete is done to create the deck slab. Now, with this method in a hybrid system, we are leveraging the advantages of each material, but however, the connections have to be done properly. For example, here in the steel girder and the cast in place, we need to have a good shear keys. Okay. Usually shear keys are provided. Okay. So, to create that composite action, and this is optimal for complex architectural projects. Okay. So, in this chapter, we are going to focus on composite construction using concrete and concrete combinations, right. So, in that we have two types of construction. One is a propped construction, as you can see here. This is your pier, okay, and these are the brown colors are basically your girders, right. These are your girders. Now, in addition to the pier support, you also have support from these props, right. So, these are basically additional temporary supports. These are temporary supports. Temporary supports, right. So, when I do that, the girder is going to deflect only between the props. So, the deflection is going to be very minimum, because more the number of props, the span for the girder is going to come down, and while I pour it, the concrete, the deflection is going to be small. So, you achieve the composite construction in a very short period of time, because as you know that concrete is going to harden very quickly, right. So, it is going to set very quickly. So, in a very quick span of time, you achieve better composite features between the deck slab and the precast girder. Now, another common method is you do not have these props, the supports are only given between the piers or pier caps, the girders are supported only there. So, because you do not have additional supports from props, you call this as an unpropped construction. Now, again as you see, if the supports are not there, you have a longer span, then the deflections of the girder can be quite higher, then you cannot really achieve the composite construction in a quick fashion. But once the concrete hardens, still you will achieve the composite construction. So, the way that the dead loads are getting transferred depends upon whether you have props or unprops, that we will explain it through an example. Now, what are the types of composite construction? Again, in propped construction, temporary props, as we explained, support the beams during the slab casting, and the props carry the beam sulphate and wet concrete, and full composite section is going to resist all the dead loads. So, this is the key difference. In unpropped construction, no temporary supports exist during the slab is being cast, and the beam is going to carry its own weight and wet concrete, and composite action will begin only after the slab hardens, right. So, what are the different load stages? Stage 1 is the initial conditions of transfer, where pre-stress PI be there, and then the sulphate of the precast girder will be acting. So, because while you transfer the girder, the pre-stress to the girder, you will have the initial pre-stress and the self-weight of the girder only will be acting. In stage 2, you have erected this precast girder over the support and then you start pouring the concrete. So, this is the condition at the time of placing wet concrete on girder, where at that time you must have passed on some time before you place it. So, the pre-stress will become effective pre-stress and you have both non-composite and composite dead loads. So, the live loads will be typically you will have both dead loads. Some part of the dead load will be acting as a composite section, it will be transferred as a composite section, and some part of the dead load will be transferred as a non-composite section. Then we have final conditions. The entire composite action is achieved. Your pre-stress, depending upon the time where you are doing the calculation, the pre-stress can further reduce or after the losses. So, plus you have all the dead load and service live loads are going to be acting. So, this is the final condition. These are the 3 stages that we are looking at, and the final condition, stage 4, is the ultimate condition. The structural system can see its ultimate state only once, right. So, you reach your maximum capacity only once. So, this is a stage 4. So, you consider for the factored overloading, and here it is going to act like a flange section. So, there is some strain discontinuity will be there, but because at ultimate stage we are looking at it and a lot of redistribution of stresses will happen. So, we ignore that small strain discontinuity. We are going to analyze it like a regular flange section that we have discussed in flexure module. Okay, let us now explain what are the different load stages. In stage 1, you can see here you have only the precast pre-stress girder, and this is your CGS. That means your eccentricity for the girder for the pre-stressing strand is going to be from the CGC is here, from here to here is your eccentricity of the pre-stressing that you have on your pre-stress girder. Now, because I am applying the pre-stressing in the bottom of the girder, as you know that you will have the effect of pre-stress plus the effect of the self-weight of the girder itself. So, that will create some stresses, but we know that that is going to be compression at bottom and then tension at top fiber, right. And at CGC, whatever the stress is the average pre-stress that you are going to have. Now, in stage, these are the stress states in the stage 1, where only precast pre-stress girder is there. While you transfer the pre-stress will be Pi and the self-weight of the girder will be there. Now, these are the nomenclature typically that we are going to use. P0 or Pi, typically Pi for the pre-stress at transfer after short-term losses. P is the effective pre-stress during the casting of the flange after long-term losses, and MSW and DG are the moment due to the self-weight of the precast web. Okay. So, either you call that as a DG, the self-weight moment, or MSW is the self-weight moment for the precast web, because this is done using precast and this will form the web in composite section. Okay. So, MCIP is the moment due to the weight of the cast in place flange. Okay. Now, we will go to the stage 2, where we are pouring the wet concrete on top of this precast pre-stressed web girder, right. So, this is the condition. As you can see, while you transfer the pre-stress, you have the effect of pre-stressing plus the self-weight of the girder. This we have already seen. This is coming from stage 1, right. This is from stage 1. Now, in addition to this, while you pour this cast in place concrete, you are going to create moment because of the weight of this wet concrete, right. So, that is going to create some stresses, right. That is going to create compression at top, assuming that the girder is simply supported, and it is going to create tension at the bottom, right. So, this is due to the pouring of the concrete from weight of your cast in place concrete. So, when you add them up, you get the entire section may be in compression. So, that is what we are trying to look at it. So, PE is the effective pre-stress during casting of flange after long term losses. DS is the dead weight of the cast in place slab that we talked about. Now, what is the final condition stage 3, while it is in service? Now, what is that condition is going to be? Now, this is stage 1 plus stage 2 that we talked about, including the weight of the cast in place concrete stress. Typically, we make sure that the precast web is going to be entirely in compression, typically. Okay. Now, the composite action has been achieved, but having said that, this will have one elastic modulus because this was already cast in the factory and you brought it. So, the age of that concrete is going to be much higher. So, the slab that you poured as a cast in place slab will be younger than the precast girder. Typically, the deck slab will have lower strength of concrete, sometimes it can be same strength also. So, what will happen is, instead of the full effective flange width, we need to reduce the flange width effectively, because we have to consider the modular ratio to calculate your actual width that is part of the section. Now, both of them will act together as a composite section. So, you get your properties. Now, this is your CGC, of composite section. So, the CGC will try to move up compared to the precast segment, and the top and bottom fibers are YBC and YTC, and you can see the depth of the interface is typically denoted as YIC at the interface, YIC. Now, this is the service stage. Now, other extra dead load and live load, everything will be acting, and that will be resisted as a complete composite section, right. So, that is going to create, say, compression, and this is tension, right. So, this is tension. So, this is now this entire composite section is going to transfer the stress. So, when you add them up, that is how we get compression here, this is compression, probably the entire thing will be compression. Let us say this is, we are writing here as compression. So, this is compression, this could get into some tension. So, let me write this as plus. So, this also can become plus. Okay. Tension we are taking it as positive, compression we are taking it as negative.